planetary gear.
Okay, so this is a 4-to-1 planetary gear. What is this? This is
it just holds the shaft that connects to the thing. It's made out of Delrin.
Yeah, so it's basically a bearing.
Right. We looked into bearings, and Delrin's actually cheaper.
Metal on plastic is a reasonable bearing surface.
It's okay.
Yeah.
Right? It was cheap. We wanted cheap, and bearings were just too expensive, and they required and the lubrication for them.
Yeah.
The goal is to have this to be 5 years maintenance free.
Yeah.
So and then there's just a spider coupling, and then we made these.
Spider coupling is just like a universal joint.
Yeah, there's a hex. An Allen set screw that clamps into the small shaft coming out of the small shaft has a pinion that goes into the planetary gear, and the other end of the shaft is connected to that end of the spider coupling, and then this spider coupling is connected to this crankshaft, and then this crankshaft is seated in this Delrin.
So this thing right here, these two areas, these are just basically it's basically a shaft going through a bearing. That's basically the intention, right? Or
it's just metal.
Yeah. So you want something better than a metal to metal.
Yeah, like we thought about
like metal with like steel on brass, for example.
Something. Yeah, this is the constraint. The constraint on this is we thought about brass clevises actually. Yeah. And I am not a mechanical engineer, so I'm just remembering what these mechanical engineers told me, but. The constraint, and we have this crankshaft made by a wire bending firm in Chicago.
Got it.
And so they make 300 for $300.
Okay.
And we can use half of them. The other half aren't done exactly.
They're a little crooked.
Right.
Yeah.
So we get 50% failure rate, but then it's just $1.50.
Yeah.
It's just $2 each.
Yeah.
Right. So that's a cheap component for us. But it has to be made out of a certain kind of steel. Cheap. It's some cheap steel that can be bent. You could bend more expensive steel.
Yeah, the crankshaft is some bendable
just wire.
Yeah.
Right, it's just some bendable steel. I forget the type of steel it is.
Yeah.
But that's a constraint. We can't change that material very easily without having dramatically increasing cost.
Sure, because it's so easy to bend.
So it would have to be the clevis. It would have to be changing the clevis thing made out, and it should be easily machinable.
Yeah.
So brass maybe.
Yeah, why don't you just make it out of brass? Oil impregnated brass is a pretty good bearing surface on steel.
We've talked about that. That's a great idea, and I think we just ran out of time.
Yeah.
For that, so maybe we should do that.
Okay.
Because that is a constraint with the senior design teams. They work on a finite calendar.
Yeah. Okay. And another pillow block just to hold the crankshaft.
That's correct.
Okay.
Yeah. And then this is just 2 blocks it's basically a manifold system. So there's 4 holes going this way and some holes going that way to connect all the inputs and outputs of the
pistons
of the one-way valves.
Yeah.
So that the flow out goes out. The flow in always comes in one way and always comes out the other way. This is actually missing a piece. It's missing this tubing that's going from there.
Where's that supposed to go? Outside.
There's a coupling. There's a little thing that goes on the outside of this, and then goes into the tubing there. That's missing.
Is that's getting the air from the outside?
Yeah.
And this is some type of filter?
This is standard filter for a Pulmo-8 nebulizer.
Well, that's the one that needs to change every 6 months, right?
Yeah, it's when it gets dirty.
Yeah.
Is that pretty easy to get? Or just a regular?
Yeah, they're $1.
Okay.
Or less than $1.
Sure.
So.
Okay. Wonder if you could get that cheaper somewhere else too.
Well, this is the first one we were using this instead of what I've normally used is cigarette filters, which are really cheap.
Yeah.
So cigarette filters are just smaller.
Air filters are very, very simple technology. That thing costing $1 sounds pretty high. I mean, I know it's a small part of the total cost, but
it's $1 when we buy it 1 or 2. Right?
Yeah. Okay.
If we bought 1,000 of them, how much would they be?
Yeah.
If we made ourselves.
Sure.
Right.
So right now we're not OEM.
Yeah. Sure.
Right?
All right, so it's basically a network of tunnels inside this with one-way valves.
That's a machine part. That could be cast. It could be.
Why is there 2 of them? Is it because there's holes in the bottom? Oh, okay. You're forming kind of a matrix of tunnels.
There are 4 connections to the pistons. 1, 2, 3, 4, and those go in there. And there's 2 connections. 1 input, 1 output.
Okay.
One from room air from coming out, and 1 going to the nebulizer mouthpiece itself.
Okay.
So there's 6 connections. So these have 2 holes going that way, and 4 holes and 8 holes going 4 holes going down there and 4 holes going down there. And the way you move the one-way valves, the way you put them in, dictates that coming out here, it all works out.
Okay, I'm sorry. There's 4 holes going this way. Where's the other 4 holes?
The 4 holes going this way, and then there's 4 holes going down.
Down.
1, 2,
Okay.
3, 4, and
Got
another
it.
4 going down. 1, 2, 3, 4 on the upside of that.
Okay.
That these, if you can see,
Yeah,
that
there's 4. So there's a total of 8 check valves.
there are 8 check valves.
Okay, got it.
So right, and it's just configured so that it works.
Yeah, yeah.
I mean, I could draw you that.
Yeah, I'm sure I could.